Data sufficiency, question 233. A citrus fruit grower receives $15 for each crate of oranges shipped and $18 for each crate of grapefruit shipped. How many crates of oranges did the grower ship last week? So here we are dealing with the data sufficiency question in the form of a word problem. While dealing with data sufficiency word problems, the best thing to do before jumping into the statements is to deconstruct the question stem itself. The question stem tells us a citrus fruit grower receives $15 for each crate of oranges that is shipped. So if he receives $15 for each crate of oranges, let us keep the total number of crates shipped to be O. Similarly, he receives $18 for each crate of grapefruit shipped. So let us keep the number of crates of grapefruit to be G. So the total amount that the citrus fruit grower earns is going to be the cost of each orange crate into the number of crates plus the cost of each grapefruit crate into the number of crates. And here the question asks us to find out how many crates of oranges did the grower ship last week. So we need to find out what is the value of O. So this is the value data sufficiency. We need one definite answer for O. Now evaluating the statements individually, the first statement gives us that last week the number of crates of oranges that the grower shipped was 20 more than twice the number of crates of grapefruit shipped. So O is equal to 2G plus 20. Now clearly here the value of O would depend upon the value of G. So if we plug in different values for G, we are going to get multiple values for O, and it's impossible for us to get one definite answer for O. So the first statement is insufficient and the three possible answer choices are B, C and E. Now evaluating the second statement individually, last week the grower received a total of $38,700 from the crates of oranges and grapefruit shipped. So 15O plus 18G is 38,700. Dividing throughout by 3, we get 5O plus 6G is equal to 3 ones are 3, 3 twos are 6, 3 nines are 27, that is 12,900. Now one mistake that people are going to commit here is to discard this equation saying that it's a linear equation with two variables, so I need another equation to solve. Remember, on the GMAT, it is possible to solve for a linear equation with two variables by plugging in values for the variables. So the best thing to do when encountering a linear equation is to plug in values and see if you get multiple answer choices. If we get multiple answer choices, we can discard that statement. If we don't, then we can say that the statement is sufficient. So here, the first value I'm going to plug in for O is going to be 180. The reason I'm plugging in 180 here is because 180 into 5 is 900, and if I subtract 900 from 12,900, I'm going to get 12,000, which I know is perfectly divisible by 6. So if O is equal to 180, G is going to be 12,000 divided by 6, which is going to be 2,000. So one possible value for O is 180. Another value I can plug in for O here can be 60, because 60 into 5 gives me 300. 12,900 minus 300 is 12,600, which is again is perfectly divisible by 6. So O is 60. G is going to be 12600 divided by 6, which is going to be 2,100. So O can also be a value of 60. So since this linear equation gives us two possible values for O, I don't get a definite answer. The second statement individually is insufficient. Now combining the two statements, we have O is equal to 2G plus 20, and we have 15O plus 18G is equal to 38,700. Now here we have two equations with two variables. We can definitely solve the equation simultaneously to get one definite value for O and one definite value for G. Since it's a data sufficiency, I don't need to find the exact value. I just need to see if the statements combined give me one definite answer for O. They do, so the answer here is Charlie.